We often use maps to visualize spatial analysis. However, visual clutter makes map visualization ineffective. Imagine a scenario where we visualize 2D spatial points on the map, either by dot distribution map or heat maps. Moreover, how about when we try to visualize multiple distributions or multivariate distribution in one graph? Here, we propose a new visualization, IEEE IEEE uses the homographical projection to map the spatial dots clusters of the distribution to a boundary band and color encodes the densities of these clusters. It uses the area offset from any arbitrary boundary to display the distribution. The colors on the map encode the densities of the spatial data clusters on this offset area. First, it frees up and saves the graphical visualization space. Secondly, it assists the users to quantitatively determine the clusters inside the distributions regarding the cluster's size, relative locations, and peak values. Furthermore, it facilitates the visual comparisons for multiple and multivariate spatial distributions. So, how does the algorithm work? Firstly, we offset the distribution boundary to yield a stripe-like space for visualization. Secondly, we divide the boundary and the distribution area into subregions accordingly. We later compute the density for each subregion with the assistance of maximum inscribable circles passing through each dividing node on the boundary. In the diagram, dots of the original distribution in the blue region are homographically projected to the right region. Lastly, we smooth the density of the target cell by normalize the neighboring cell's weights and use the color scale to encode the density on the edge. How efficient it is! We conducted a human subject test to investigate the efficiency of IEEE by asking the users to localize the clusters and estimating the peak value for each user-circled cluster density. Our analysis shows that the users are able to utilize IEEE to localize the clusters inside the distribution, and they can give a close estimation of the density value for each cluster they drew. We demonstrate how to apply IEEE in different scenarios. In this figure, users visualize Buddhist and non-Buddhist building locations in Hunan Province, China. Same technique could be applied to resolve off-screen visualization. In the second application, 3 adjacent boundaries are visualized by IEEE. The observers are able to compare the densities between the subregions.